So here's our portion on determining parallel or perpendicular. We've worked with this before. So to focus in on what we're looking at, we want to look at slope, and that of course is the number right before the x. So here we have a slope of -1, and we want to compare that to the slope in the second one. But notice here we don't have the y by itself. This is not a y equals equation. So what we need to do is we need to move the 3x to the other side to get a y equals equation. When we do that, notice the slope is now -3. Let me write that so it's more legible. So when I compare those two slopes, I see that they are not the same. That would indicate parallel. I see that they are not opposite, reciprocal, which is the perpendicular situation. So this must be a neither answer for this one. For number 2, in a similar way, let me grab the arrow. We are looking for the slope. Notice there is no number in front of the x. That of course indicates a slope that is 0. And for the other line there is not even a y equals equation. So we need to think about this maybe a little bit differently. Try to line everything up here I want to line up. Alright, stop that. So, if you realize y equals 6 is going to be a horizontal line, x equals -2 is actually going to be a vertical line. And by definition, those two lines actually intersect at a right angle. So here's a situation where even though we do not have slopes to compare, we can conclude that these two must be perpendicular. For our third one, number 12, let me see if I can get this arrow out of the way here. Oh, there's another one. Get rid of him. Yeah, let's try to grab this guy and move him out. Okay. For the next one, it might be convenient to do our work on a separate page, because here it might take a little while to get this into y equals form. So I will scoot to the next page. Let's see. 5x minus 3, y equals 4, and 15x minus 9y equals 0. And we can look at these. Okay, 5, grab a pen. 5x minus 3y equals 4, and 15x minus 9y equals 0. Okay, so I need to move the 5x by subtraction to the other side. We're trying to set up, and I'll do the 15 guy at the same time. I can do that. So now in equation 1, I am left with -3y equals 4 minus 5x. So it's starting to set up and look a little bit better. The second equation will be -9y equals 0 minus 15x. So I'm getting closer. Now I think we see that the step is to divide by -3 here and here. And then in the second one it's going to be a similar step. We divide here by -9 both places. Once we do that, we end up over here, and I'm not concerned with what happens with the 4. That's a y-intercept. I just want to look at slope for this part. So I have -5 over -3, which I think we all realize reduces, because negative divided by negative, of course, is a positive. So here we have a slope. 5/3 for the first equation. For our second equation, a similar thing will happen. The negatives will cancel top and bottom, and we end up with a positive number. At first glance, this doesn't look like a match, but if you look at that fraction, the second one, you can actually reduce that to lowest terms, both 15 and 9, divide by 3. So we will end up with 5/3 x, and lo and behold, those are the same numbers, which means then that the last one should be an answer of parallel. I would hope we could spell this correctly. The word's right here on the page. Number 13 is just like this one. we want to move parts, and by parts I mean the x piece to the other side, this x piece to the other side, and then in the first one we're going to end up, once that move happens, let's actually write the first part, 3y equals 12 minus 2x, and of course we're going to divide by this 3 to get y by itself. So it looks like my slope for the first one is negative 2/3. See if I can focus in on this a little better here. And then for the second equation, when I subtract, I will have a negative 4y equal to a negative 6x plus 24. Divide by negative 4. And it looks like I end up here with this fraction, if I reduce that to a positive 3/2, and compare these two slopes, that would be in front of the x, of course. I see I have opposites and reciprocal. So in this case, these two lines happen to be parallel. After switching things around and getting the correct format, the y equals mx plus b format for each of those. For number 14, moving right along, we need to compare slopes to decide once again. So for this equation, we want to find the slope of AB, and we do that with the subtraction fraction, as we called it. I find my y values, that's the second number in each pair, and I will start with point B right here. So that y value is 11. I subtract the matching y value from the A, the 11 and the negative 4, and that will be over the x values. Now I started with my 11 from point B. I have to start with my 2 from point B, and I'm subtracting the negative 1 from the first portion. So it looks like here the slope of AB is going to be 15 over 3, which reduces to 5. I have a slope for that one. I'll do the same process to figure out the slope of line CD. And when I do that, I'm going to go 10 minus 1. And that 1 I used would be the y value there, of course. Over 4 minus 1. And when I check those out, I get 9 over 4 take away 1, I think is what that's supposed to say, is 3. And 9 over 3 in lowest terms is 3. So are these two parallel, perpendicular, or neither? Well, the numbers obviously aren't equal, and they're not even close to being opposite reciprocals. So the answer for number 14 is apparently neither. Same process for 15. Find your slope here, find your slope here, and decide parallel, perpendicular, or neither. I'm going to start with point B again, and I'm looking for the y's first, the second in each pair, and then I started here. I have to go 0 minus negative 3. So in this one I get negative 1 over positive 3. Here is my slope for that problem. Slide this a bit, come over here. And here I have negative 6 take away 3 on top. Those are the y values. And then I subtract down below a negative 2 take away 1. So when I'm subtracting here, up above I get negative 9. Down below I get a negative 3. And in lowest terms, this will be 3 over 1. Put a box around that. And then I come back and I compare these two numbers. Notice they are opposite reciprocals of one another. That would indicate a perpendicular situation. I'm going to jump now real quick to the bottom question, then we'll come back and answer the other 4 intervening problems in a separate video. For number 20, we suggest that you draw a triangle here, and it doesn't really matter how you draw it, but just to get the ideas down. You have a point G, a point H, and a point K. And to decide if it's a right triangle, somewhere between these sides there must be a right angle, which another way to say that is perpendicular. So your job here is to check slopes of each side. You have to do 3 separate fractions and decide if any of those relationships are opposite reciprocals. In other words, I'll just do one of them for a sample. I'm going to do side GH to get a slope. You also have to do side HK, and then you also have to do side GK, which would involve the first and the third pairs. So let's do the red one. 5 take away 2 over 8 take away 3. It looks like that slope will be 3/5. So once you do a few of these, it goes pretty quickly. For the blue one, it'll be between h and k, so we have 10 minus 5 over 0 take away 8. That leaves 5 over negative 8. So far, we have no right angle. Let's check our last one. 10 minus 2 from the G pair over 0 minus 3 for the x's, and that would reduce to 8 over negative 3. So as I compare all three of these, I see no right angle relationship, no perpendicular, so we have to conclude that this is not a right triangle.